Hello students, and today we're going to look at the real number system. Your learning objective for today, so you should put this at the top of your notes, remember. I can classify and identify numbers within the real number system. So here is the real number system. This is what it's going to look like when we look at it. But right now we're just going to look at what's a rational and an irrational number. So we're going to look at the difference between those two right now. Now, rational versus irrational. Remember, if you see the pencil in the right-hand corner right here, you should definitely write these down. So, rationals, irrationals. Rational numbers makes sense. Rational means to make sense. If someone's rational, we call that they're making sense, right? Irrational, they're not making sense. You don't understand what they're saying. So, rational numbers is any number that can be written as a fraction. So that could be 1/2, that can be 2/1, that could be anything that you can write as a fraction. Fractions are an example of that. You can write wholes, so 7, which is 7/1, right? Integers, so -18. Terminating decimals. Terminating means ends. Kind of like the Terminator, so it ends decimal. That's what terminating means. Repeating means it goes on forever. So you see how that 7 has a line on top? That means it's repeating. So repeating decimals are also rationals. Now, what about some irrationals you're saying? Well, they're non-terminating and non-repeating decimals. Make sure you kind of star this and here. So it has to be both of them. And it can't be written as a fraction. Here's a few examples. Square root of 3. Because that's 1.73205, something like that. That can't be written as a fraction. And here's a bunch of random examples that you can have. Another very common irrational number. Pi. Pi is very common, especially now we're going to start looking even more at pi. That is a very irrational number, and it's very common to be called an irrational number. So now we've looked at rational and irrational. Let's go inside the rational number system now and look at those boxes that are inside there. So if you ever look at Russian nesting dolls, and maybe you've had them as a child or you actually see your parents have a pair, well, there's a big doll, and then you open it and you get a smaller doll, and then a smaller doll, and a smaller doll, and the smallest doll, actually. So when an item is a member of the smallest box, is always part of the larger box. So this is kind of how I think of it. The natural numbers is also part of the whole numbers. The whole numbers is then also part of the integers. The integers is part of the rational numbers, and furthermore, part of the real numbers. The real numbers is the big doll in the end. So natural numbers are the whole numbers. They're part of the integers, they're part of the rational numbers, and they're part of the real numbers. So think of the natural numbers as the smallest doll possible. But notice how not all the integers will fit into the whole number doll. So I can't put the big integer doll into the whole number doll. That's just not going to work. Same thing as all the whole numbers don't fit in the natural numbers. So now you're saying, well, what's the difference between integers and whole numbers, Miss Marsh? Well, let's look at that. The inside of this rational numbers. Naturals are what you naturally count and what occur in nature. Naturally, when you start counting, you didn't count 0, 1, 2, 3. You started 1, 2, and 3. So naturally, it's what you naturally would count. 1, 2, 3, 4, 5, stuff like that. Whole numbers now is the natural numbers and 0. So the only difference between these two is we added 0. That's the big difference between those two, okay? Integers then. We then added the negative numbers. Notice how there are no fractions yet. Only integers, only numbers, no fractions. So, let's place some numbers here. I have a whole bunch of numbers down at the bottom there. I need to place them into their correct and most specific family order. So, I have the square root of 2 right there. Where do you think he's going to go? He's going to go to the irrational numbers, right? What about -6? -6, it's not a whole number because it's a negative, so he's got to go to the integers. Because he's not irrational yet. He is irrational, but most likely his most specific is an integer, right? 2.73, that's a terminating decimal. So he has to go to the rational numbers. What about the square root of 9? Well, a lot of you are saying, well, that's an irrational number. It has a square root, right? Actually, think, what is the square root of 9? It's actually 3. So the square root of 9, even though it has the square root, does not mean it is an irrational number. Make sure you pay attention to those. If you see a square root of 4, that's 2. Always simplify before you start to sort. Then I have 3/7. Well, that's a fraction. It's got to be a rational number. That's just how it goes. I have negative 100. That has a negative. It's got to be an integer, right? 0. 0, remember that one wasn't part of the naturals, but it was part of the whole numbers. So he's only going to be in that space. Pi, I told you pi was, look back at the notes here. Oh, that's an irrational number, right? 3.14159 something, something, something. What about 1? 1 doesn't have a negative, so it is an integer, but I can go further. Whole number, natural, I count with 1, right? So 1 is your natural number also. Negative 1/2. Now, you're going to see that negative, you're going to be like, it's an integer, but it's a fraction. So it has to go to the rational numbers, because integers can't have fractions. Negative 3.8, that's a rational number. It has a decimal on it, which is basically a fraction. 5.42, notice how there's the 4 and the 2 are repeating. Make sure that you put that one in the rational column because it has a repeating sign. 8.293017 ... Well, it has a ... That's got to be irrational. Negative 18, it has a negative. It's not a fraction. It's got to go to the integer area. And then what about 75/15? It's kind of weird. They both end in 5s. I wonder if a 5 can come out of there. And it does. You actually get 5. So 75 divided by 15, that's actually 5. So like I said, be very, very careful as you look at these. So what we're going to do, we're going to identify each number below as a natural, a whole, an integer, rational, irrational, or real. Now, some of them may have almost all those answers. So what about negative 4/5? That one, let's think back. It's not a natural number. It's not a whole. It's not an integer. It's got to start at a rational. And then everything's real. So it's rational and a real. What about negative 9? Negative 9 starts at the integer, right? And then if it's an integer, if you think back to our dolls, it's got to be irrational and it's got to be a real number too. What about the square root of 16? I bet I didn't catch you this time. Square root of 16 is 4, right? So I'm going to mark that in. I'm going to put a 4 there, just to remind myself. So the so 4 is a natural. It's a whole. It's an integer. It's a rational. And it's a real number. That's pretty cool, right? It's got everything except for irrational. Negative square root of 25. Wait, what? Oh, square root of 25. Yeah, that's 5, right? So I have negative 5. So negative 5 is an integer. And a rational. And a real. What about the square root of 8? What is the square root of 8? No, it's not a perfect square, right? He's irrational. But even though he's irrational, he still is a real number. So don't forget about him. Don't forget about that real number system as well. That there's all of them are real numbers. And that's the end of my video. See you later.